Hello, everybody. Again, this is Chris Muslick, your instructor. This is the beginning of lesson 3 here. First thing I want to do is go through a little bit of a review of some of the topics from last week, and then we're going to go through a real simple example using Visual Studio and how to create a small program with some variables and all that good stuff. So, thinking back to what we did last week, I had you guys submit a little Hello World program. And just so we can kind of do a quick review here, let me just speak a little bit about some of the syntax or some of the components or the parts of a C++ program. This is from your book. I believe it's page 30. It may not be exactly page 30. I don't think my online book is exactly in sync with the 8th edition of my hardcover book, but nonetheless, which should be pretty close. So the first thing that you may find in a C++ program is a double slash. Okay, a double slash is just an indication to the compiler that that line of code is not necessarily a programming statement, but it's a comment. Okay, which means that it's ignored by the compiler, and typically you use comments just to document your code. We're going to talk more about it later on in the semester, and there's some different types of styles that we can use for commenting. Next thing, all right, the pound sign. All right, the pound sign, it marks the beginning of a preprocessor directive. The one that we're going to see in this class, we may see another one. I'll have to see later on in the semester. But a preprocessor directive is just a way for a bit of code behind the scenes to be expanded and included within your program. So in this case here, the pound sign is always going to be used with the pound include directive like we have here, which will include a file into our program. Next thing, open and closing brackets. These will follow a pound include directive, and this will just tell us which library or which header file we're going to include within our program. And we're going to see a lot of these. Be honest with you, we won't be able to create any programs in our course here without using both the pound sign and some include directive. All right, open and closing parentheses. These will be used for some mathematical operations, which we can see later on, and also with pairing up with a function. Right now, all of our programs are just going to simply have a main method. In this example here, this is telling me that there's a method that's called main in a program. The return type of the main method is going to be an integer, and it takes no parameters, and that's why we have the open and closing parenthesis with nothing in between. So for now, all of our main methods that we're going to create are just have an open and closing parenthesis, and that's all. Open and closing braces. Okay, open and closing braces will typically mark the beginning and the ending of a function. In addition to that, later on we'll see how they can be used with loop constructs to create logical blocks of code. We'll see a lot of opening and closing braces within this course. Just as a general note, this is a common compiler error that you'll come across. You need to make sure that you have your open and closing curly braces properly paired up. So for example, if you have 2 opening curly braces, you should have 2 closing curly braces, and they should be nested properly. If you have 2 opening curly braces and then 3 closing curly braces, okay, you're gonna get a compiler error. All right, next thing, open and closing quotation marks. All right, double quotation marks mark a string within our program. So you can think of a string just as a sequence of characters. And that's where double quotes will be used within our program. In a little bit, we're going to see how sometimes we'll actually use not just double quotes, but sometimes we'll use single quotes, and that's used for something else. It's for characters. And the last thing that we have here is the notion of a semicolon. A semicolon will mark essentially the end of a single programming statement. You may have noticed sometimes we have semicolons on some lines of our code, sometimes we don't, and that's part of the grammar and the syntax of the language is to know when you do and when you don't use a semicolon. You'll become more comfortable with this as the semester goes on. So now what I want to do is let me launch Visual Studio. I'm going to create a simple skeleton program once again, and I'm going to then begin the lecture part of this lesson. So I'm going to launch Visual Studio, which I have right here. I have my blank screen. Again, what I'm going to do is I'm going to create a new console application, and then I'm going to walk through a small example. So I'm going to click File, New Project, right? Visual C++, Win32 console application, and I'm going to give my solution a name. I'm going to call it Lesson Examples. This is going to be the solution that I'm going to be using for most of the semester to walk you guys through some of the examples of our lesson. So it's a good solution. You write lesson examples. Click OK here. Once I get to this screen, I just have to click Next. The only other option I would need to select here is the inclusion of an empty project. Okay, now, make sure you select that, otherwise what happens, you're going to get well, you may or may not get some errors with what are called precompiled headers, and it's kind of hard to fix. So anyway, just make sure that you always click on this empty project here. Click Finish. And this will create a skeleton project for me where I can then go ahead and add some source files. So the default behavior is that Visual Studio won't give you any initial content. You need to create the initial source files yourself. Easiest way I find to do that, if I just select a source files directory, do a right click, click Add. What I want to do, I want to add a new item. There will be cases where you have an existing item, like for example, when you guys email me your when you guys send me your labs, what I do is I have another solution which I use just for like grading purposes. And what I do is I select existing item, and what I do is I navigate to your source files. I then go ahead and compile and build and execute them. All right. So if you have something that already exists, you can pull it into your project. In this case here, it's a new item, so I'm going to select new. Select new item. What type of item am I going to add? In this case here, we're always going to add C++ files which have the .cpp extension to it. CPP meaning C++. All right, and I'm just going to give it a name here. So we're working on chapter 2, so I'm just going to call my main file chapter 2. All right, something that's self-documenting here, right? So it's my chapter 2 main program. I'm going to click Add. Now I have the blank source file window. This is where I'm going to put my main code. All right. First thing I need to do is I need to include the IO stream library. So once again, I click pound include, open bracket, IO stream, IO stream, and that'll give me access to all the items that are part of the input-output stream library. What am I looking for here? I'm looking for the reference to the cout object, so I have some way to display my program to the console. All right, so I'm looking for cout here. Next thing we need to do is always use our using namespace standard std. Okay, and that will allow me to view a section of the IO stream library, which is called the standard, or just std namespace. All right, so that's those 2 lines of code you're going to have to put in every program that I can think of within this semester. So just get used to having that, or if you want, you can create this, use something like this as a skeleton, and you can always just like copy and paste it into your program if you want. All right, next thing I'm going to do is, so by the way, just so you know, the line 3 is just what's called white space, meaning it's there, it's white space, it's the invocation of the enter key. The compiler ignores white space. Okay, it doesn't matter how much white space I have, the compiler will ignore that. In reality, if you wanted to, you could create an entire program all on one line, all right? And the compiler doesn't care, okay? I mean, it would be hard for us to read, hard for you to read, but nonetheless, the compiler is just a machine, and it just ignores white space. So white space is there for us, right? For us to be able to read the stuff. All right, next thing I'm going to do is create my main method. All right, I'm going to for now I'm going to use what's called a void return type. We're going to talk more about return types and functions later on, and I think it's like chapter 4 or something. But for now, I'm always going to have a void main function. What void means is that my main method right, or my main function isn't going to return anything back to the operating system. Okay. So there's main, open and closing curly bracket. That's it. All right. So now my main method again, once again, that's the entry point into my program. So my program initially kicks off. Line number 5 here, this is where my program is essentially going to begin. I guess technically it's going to be on line 4. Okay, that's where my program is going to begin. Let me talk a little bit more about the cout object and how we can kind of do some manipulation. All right, so let me just do a little cout. Remember, this is referred to as a stream insertion operator. So whatever's on the right of my stream insertion operator is going to get shoved into cout. What is cout going to do? Cout is an output stream which is connected to my console. So what it will do is it'll take whatever I'm shoving into it and display it on the console. There are times where you're going to have an output stream, which might be, and we'll be doing this during this semester, an output stream which could be, for example, a file. All right, so what I could do is I could shove things into an output stream, which will then persist out to a file on probably my local hard drive or maybe my flash drive or whatever it might be. So cout is just what's referred to as an output stream. And again, in this case here, it's connected to my console. All right. Cout, and then here we're going to start off with some simple things. I'm just going to say this is line number 1. This is a programming statement. Since this is a programming statement, I need to terminate this with a semicolon. If you don't put a semicolon here, you'll get a compiler error. Right? I'm going to do another one. Cout. This is line number 2. And one more. Cout. This is line number 3. All right, I'm going to go ahead and build this thing. So build solution, F7, whatever you want to do will work. What's going to happen here is I literally am just shoving this string, which says this is line number 1, this string, which says this is line number 2, and this string, which is this is line number 3, into the cout object, and the cout object will then send it to my console. What's going to happen here, though, is let me execute this thing. If I run this, notice what happens. All right, where it says this is line 1, this is line 2, this is line 3. Notice that they all appear on one line. Why did that happen? Because I didn't explicitly send anything to the cout object to force it to create a new line. Okay. What I'm trying to say is that even though I have this, these 3 lines of code or these 3 statements being fed into my cout object on different lines visually on my editor, the cout object only sees that as 3 strings, and it'll just treat those 3 strings just as they're strings, and that's it. So that it won't actually invoke like the new line character. If we want to have a new line character sent to the cout object so that these 3 lines actually do span 3 lines on my console, that's when we need to go back in here and do one of 2 things. The first thing I'm going to show you is like what we did last time when we feed it the what's called the endl operator. Okay, so once again, I'm going to use the stream insertion operator here and type endl. Endl just stands for end line. I think I talked about this in the last lesson. So end line will is a statement. Okay, actually, it's not a statement. Endl is a flag or an indicator to the cout object to treat that thing as a new line. Endl is operating system dependent, so Endl on a PC is probably slightly different than Endl on a Mac, which is probably slightly different than Endl on a Linux machine. But if you use this, we're dealing with what's called ANSI C++. So if you compile this code on a Linux or a Mac, you would get the same exact output. Okay, that's the idea. All right, let me do another one here. So I'm going to type Endl. All right, and one more. Endl. Now if I go ahead and build this here and run it again, what's going to happen is first we're going to feed in, this is line 1 into cout, then we're going to feed it endl, then we're going to feed it, this is line 2 to cout, then we're going to feed it endl, then we're going to feed it, this is line 3, and we're going to feed it endl. So what that is going to do, it's going to force our program to then write across 3 lines on my console output. So if I execute this thing, you'll see now it says this is line number 1, this is line number 2, and this is line number 3. All right. This is what I want to mention. So endl is actually what's formally called a stream manipulator object, meaning that it does something to a stream. In this case here, it forces a new line character. So again, that's what I was trying to say. It's a stream manipulator object. All right. There's also another way that we can force a new line within our program, and that is by using a what's called an escape sequence, which will allow us to put something within our string itself to force a new line to occur. So what I'm going to do here is let me get rid of the endl here. Let me get rid of endl here, and I'm going to get rid of endl here. And now what I'm going to do is at the end of my string, before the double quote, okay, I'm going to type what's called an escape sequence, which is just \n. Okay, \n is a indication to the cout object to treat the pair of characters / and n as a new line character. Very similar to how endl works. The only thing with the \n, it's not necessarily operating system. I'm sorry, it is operating system dependent. So if you do this on a PC, we'll get the desired results. But if you do this on a Mac or a Linux machine, you may not necessarily get the same results. Pretty certain you will, because the compiler will probably take care of that for you. But nonetheless, this is just an alternative way to create your code, giving your code the ability to span more than one line. During the course of the semester, you're free to use whatever you want. If you want to use \n or endl or any combination thereof, that's fine too. So nonetheless, I'm going to build this again, or hit F7, Control F5, and now you see that we get the same results, saying that this is line number 1, this is line number 2, and this is line number 3. All right, enough of that. Let me go back to the book, all right, and let me show you some other characters that we can use that are called stream manipulators and escape sequences. And I believe these are on, let me see if they're on page, let me pause for 1 second, I'll be right back. I think they're on I'm not sure exactly what page you're on. Let me just go ahead and find them. All right, I found in the book, it looks like it's on page 35, on table 2-2. These are the common escape sequences, and we'll be using a few of these throughout the semester, actually quite a bit. So what happens is, if we want to feed something into our cout object embedded within a string, we can put these little escape sequences or manipulators into our string, which will cause our cout object to perform a particular operation. All right, we saw the first one a minute ago, whereas if I feed it \n, what does that do? That will create a new line within my program, which will cause my cursor to wrap around down to the next line. Okay. Here's another one which is common. So if I use the \t in my program or within a string, that'll force a horizontal tab to be invoked within my cout object. \a, most of the time this doesn't work. It could cause your computer to beep. You can try this. It doesn't work on my PC. Most machines it doesn't work. I don't know why. \b will cause an invocation of the backspace key, which is backing up one character. \r we won't typically use in this class, but it'll cause your cursor to go to the beginning of the line, not to the next line. Not so commonly used, but it's there. You can play around with that if you want. \. So what happens if we want to actually print the \ character within our program? All right. In order for us to do that, we actually have to precede the \ with another \. So we have to escape the \ character with a \ key, which will enable us to have the \ character printed. Likewise, what if we want to print a single quote or a double quote? Well, in order for me to have the ability to print a single or double quote, I need to precede a single or double quote with the backslash character in order to have that display. Otherwise, you're going to get a compiler error. So your quick note warning, when using escape sequences, do not put a space between a backslash and a control character. So these two guys need to be paired together. So if you want to have a double quote, it's backslash double quote, and make sure that you don't put a space in there. All right. So let me go back to my IDE and let's try a couple of these. All right. So we already saw how \n works. Let's go ahead and take a look at maybe a couple of the others real quick. Have some time. All right. So let me illustrate how a backslash how a tab character will work. So let me type cout. All right. And let's see what we should do. I'll do this. Oops. Double quote. This is a backslash. Let's do this horizontal tab. So what's going to happen is here when the cout sees this, it's going to see that this is a, and it's going to come across \t. It's going to interpret that as the invocation of the tab character on your keyboard, and then it's going to display horizontal tab. Okay. What if I want to display a backslash? All right, this is something that you're going to need to do sometimes in a program. So if I want to display a backslash, say this is a backslash, all right, backslash. Let me put my endl in here, over here too, just so this stuff is comes out on the screen nice and neat. Endl. Just so you know too, make sure that when you use the stream manipulation, the stream insertion operator, just remember that each stream insertion operator can only operate on what's called operand. So if I want to feed multiple things into a cout object, I need to have one stream insertion operator per element. So for example here, right, if I want to feed in, this is a backslash, I need to use this stream insertion operator, and then if I want to have something else go into cout, I need to have another stream insertion operator and then feed in endl. Okay. If you don't do that, then you'll get a compiler error. Double quote. All right. So let me show you how you can do a double quote. So cout. This is a backslash double quote. So what's going to happen here is, here I have the backslash double quote, and here I have a backslash double quote. What will happen here is the cout will see that, and it will display the double quote onto your screen. Okay, so without this, I would get a compiler error. Just think about this logic. What happens if I get rid of this and I get rid of this? Okay, well, the compiler is going to look at this and think that this is a string. It's going to look at this and think this is a string, and it finds something in the middle that's not wrapped in quotes or double quotes, and it's going to think that these are some kind of identifiers, and I haven't properly defined them yet, so you're going to get a compiler error. So let me put them back. Use my old friend Control-Z on a keyboard. All right, gets me back to where I want to be. So let me build this thing, and let's see what happens. Again, I would suggest go through some of the other escape sequences if you want, like the backslash single quote, the backslash B for the the backspace, and what was the other one? You can try backslash A, see if that works. Backslash R. Again, there's a couple of them on table 2.2. I'd suggest you give them a try. Right? Good exercise. Let me run this thing. Let's see what we get. Okay, so here you can see, right? It says this is a horizontal tab. So all I put in my code was \t, and that actually invoked the tab character. Next line, right? I said this is a backslash, right? How did I display a backslash? By actually having my backslash preceded by the backslash character. All right. And the last one, right? This is a double quote. All right. How did I get the word the words double quote wrapped in double quotes is by preceding this double quote with the backslash and this double quote with the backslash. All right. So that's it for this section. Play around with this. Try to create some compiler errors on your own. Maybe play around with some of the other stream insertion, the escape sequence operators, and see what you get. All right, now let's move on to the next section of the book. And here we're going to talk about variables and literals. All right, now what I want to start covering is the notion of variables and literals. Your program will almost always, operate on some type of data. So, for example, here, the little program that we have on our screen right here, my program operated on a bunch of what are called literals, meaning that these are hard-coded values that are in my program. And the hard-coded values in my program are those several strings. Quite often your programs will get data from somewhere other than hard-coded values within your program, and you might get data into your program from a file, from a database, from a web server, whatever it might be, and your program will operate on that data. For the examples that we're going to be doing in the beginning of this course, we're going to get data into our program by hard coding the values as what are called literals, or storing values in variables. So let me get rid of what I have on a screen here and show you how we can create a variable or an identifier. Actually, before we even do that, let's say I want to display, I don't know, something that's not a string. Let's say I want to display a value to the screen, the number 10. All right. So what I'll do is let's type cout, stream insertion operator 10, endl. All right. Cout is going to get the literal value 10 inserted into it. Then it's going to get the endl sequence, and then it's going to display to the screen. If I build this, you're going to get what you think, right? We're just going to see the value 10 up here on our screen. So this value 10 here is what's called a literal. More commonly, you will use variables, which will allow you to have little places in memory where you can read and write values to and from. So, for example, let's say, let me go back up to here, and here I'm going to create a variable. Right? Most of our variables are going to be, at this point in the semester, or actually in this course, most of our variables are going to be what are called primitive types, meaning that they're going to be things that are like numeric values, which could be integers or floating point values, characters, Boolean values, things that can be true and false. They're going to be some of what are called the primitive types. So what I'm going to do here is I'm going to create a variable of type int. I'm going to talk more about ints in a little bit. I'm going to give it a name. I'm going to call it value. And I'm going to assign that the number 10. All right. So what happens is, in memory, somewhere there'll be a place reserved for us. We're going to associate that place with the word value. And what's going to happen is we're going to store the number 10 in that location in memory. Once I have that variable, that which is called value, I can then go ahead and freely read and write from that memory location, use it for whatever purpose I need. So right now what I'm going to do is I'm just going to use the variable value within my stream insertion operation and display whatever the contents are of that variable. In this case here, it's equal to 10. Let me just change it to 20 just so you can see that it's different from what was before. And now when cout sees that variable name that's called value, it will then go ahead and read the contents of that memory location and display the value. So let me just build this real quick, run it, and you'll see that, oh, hit the wrong key combination. I run it, and now you see that we display the value 20. I can also change 20. All right, so since value is some location in memory which has a value, I can change that value. So here I could say value is equal to 10 plus 50. Okay. So what I'm going to do now is I have a place in memory that's called value. I'm going to assign that the number 10 or the evaluation of the expression 10 plus 50. So it's going to do a little bit of math, add those two numbers up, and store that in value. Now if I run this, you'll see that I'm going to display the value 60. Okay, so variables are unless you explicitly say otherwise, you're able to read and write from those memory locations. There are other data types other than integers, and we're going to see a little bit more of this in a couple minutes. Just bear with me. And there is another data type that is called a floating point data types, and one of the more common ones is what's called a double. And I'm going to introduce it to you now, but we're going to see a lot more of this later on. But real high level, integer types are values that are whole numbers. Okay, floating point types such as floats and doubles are values or data types that can store decimal precision numbers. So, for example, let's say I want to create a variable of type double, and I'm going to call this I don't know. Height or something, height, and I'm going to declare it and initialize with the value of I'm like 72.3 or 72.5. Okay, so I will be able to store fractional values in the variable height because I'm defining it as type double. All right. Now you could do the same thing as we had before. I could do cout, height, basic stuff here. Right. Run this thing, and you'll see that we display now the number 60, right, and the value 72.5. All right. When we create variable names, okay, both the identifier value and the identifier height are variables in my program. There are certain rules within the programming language on how you can name your identifiers or your values. The very first rule is, let me flip back to the book here, is the very first rule is, and I believe this is on page 42. Let me just make sure it's in sync with what you guys have. No, it's actually like page 43 of your book, so this is off. Sometimes it's plus or minus a page. So if I have this up on my screen and you go to the book and you don't find exactly what I'm looking for on this page, you might just need to flip back and forth a page or two. All right, so the first rule is this table here shows you all of the keywords that are part of the C++ programming language, and you'll see there's quite a few of them. A lot of them we're not going to even be exposed to in this course, just due to the nature of the materials that we're going to cover. So these are what are called keywords or reserve words, and these have some special meaning to the language, and they're things that you can't use for variable names. And we've seen a couple of these already. Like for example, this one over here, using, right? We used this in our program before. What's another one? Namespace. I wish that window would go away. So like this guy here, right? Namespace, right? We used that before. We use this one here, int. Okay, we use the word int. I just used double, which is somewhere, right? Here's the word double. What's another one? Void, right? We've seen the word void before because it's right a return type of a function. So in essence, that when you're working in your IDE, all of these reserve words will show up as below. Okay, they'll be in blue font, meaning that they have a special meaning, and you can't use them for your variable names. Another rule is, and I think they have legal identifiers. Cool, it's right here. All right, here are some other rules. All right, the first character of your identifier must be a letter. Okay, it could be either lowercase or uppercase, or the underscore character. So your identifiers or your variables must begin with either a letter or an underscore. After the first characters, then you can use letters, upper or lowercase, numbers 0 through 9, well, right, the characters 0 through 9, or underscores. Okay, so then you can introduce numbers into their identifier names if you want. Remember C++, upper and lowercase characters distinct. What does it mean? It means it's case sensitive, right? So the language is case sensitive. So lowercase a is treated differently than in uppercase a. In addition to that, it's not specified. It doesn't tell you here, but this is another rule: is that your identifier or your variable names can't have any spaces in there. Okay, just I guess implicitly it does tell you here you can't have any spaces. So let me show you an example of a legal identifier and something that would be illegal. Or let's just look at the examples that they have here in the book. I think this is probably better. So here's a variable name that's called day of the week. So this is just a variable name. It's not telling you what the type, which is fine. Is this legal or illegal? Let's see. Well, this is legal. Why? Because it begins with a letter or an underscore. In this case here, it begins with a letter, and there's no spaces, so that looks good. This one here, 3D graph, this isn't legal, right? The reason is because it begins with a digit. You can use digits in your variable names, but it just can't be the first character. Underscore employee num, is that legal? Yes, it is. Why? Because it begins with a letter or an underscore, right? So that's good. Here's another one, June 1997. Yes, this is legal, right? So it begins with a character, begins with a letter or an underscore, and then it does have numerical values within it, but they just happen to not be one of the beginning characters, so you're good. That's fine. That's legal. And the last one, mixture pound 3, that's illegal. Why? Because you can only use letters, underscores, and digits. You can't use any special characters like the hashtag or periods or the exclamation mark or the asterisk or any of those other special characters. So those are invalid. All right, let's move on to the little bit further details of the integer data type. So let me talk a little bit more about the integer data type. This is one of the most common data types that you're going to use in programming in general, not just with C++. So an integer data type is a type of number that is just, you can think of it as just is a whole number. It's something that doesn't have a fractional or a decimal representation with it. So let me go back into my screen here and let me kill some of this. Let me get rid of this. Let me get rid of this. And let me go back up to what I had before. So here I have a variable that's called value. It's of type int. Okay, notice it's blue, right? This is one of the reserved words in C++, and I'm assigning it the value 20. This is a common way to do what's called declaration and initialization of a variable. You can also just declare a variable, okay? And then later on, you can initialize the variable with a value. So let's say down here, right? So line number 5 tells me that I have a place in memory that's called value. I can refer to that place in memory via the word value, where I can freely read and write values, or I can freely read and write integer types to that memory location, but nothing else. Since C++ is a type-safe language, if value is a type int, right, meaning it's an integer, I can't stick a string in there. I can't stick a double in there. I can't stick a Boolean value in there. I can just stick integer types in. If you try to break the rules of the language, what's nice is that since C++ is type safe, you'll get a warning or an error depending upon how severe the error is from the compiler, and you'll know that something's not right. So now that I have now that I have value there, I can then go and say, all right, well, let me say value is equal to 99 or something. Okay, semicolon, end of a statement, and now I can go ahead and use value within a cout statement. So on line 6, what I did on line 6 is this is where I actually initialize the variable that's called value. I can then go ahead and consume value within my cout statement. I can go ahead and continue with value and say value is equal to itself plus 1, okay? And now value is going to change, okay, because we're going to read whatever the value is of, we're going to read whatever the contents are of value. We're going to add 1 to it. Right, so we're going to do a little bit of math here. And then once we're done, we're going to assign the result of this expression and store it back in to the variable that's called value. So this guy over here, this operator, which looks like the equal sign, it's fair to think of it as the equal sign. What the formal name is that is called the assignment operator. And the way that the assignment operator works in C++ is whatever is to the right of the assignment operator will be evaluated as an expression, and then the evaluation of that expression will then be assigned to whatever is on the left side of the assignment operator. These things need to be apples and apples. So if what's occurring over here is a integer type expression, I can then freely go ahead and assign that into my variable that's called value. If what I do over here is not an integer type expression, okay, the compiler will complain and say, oh, you have something to the right of the assignment operator, which is let's say a double, but you're trying to put it into an integer, and that's no good. So let's say, for example, I do something like this, it changes to 1.1. If I do that, actually the compiler is not complaining yet, but I would imagine if I build this, I compile it, okay, I get a warning. Okay, when you're working with your IDE and you get errors or warnings, what you can do, the simplest thing is if you just double click on a line, it'll bring you to that error or that warning, and here it tells me that, you know, conversion from double to int, possible loss of data. So what the compiler is going to do is it's going to look at 1.1 and it's going to convert that thing to an integer, add it to the value of whatever value is, and then assign it to itself once again after the expression is complete. So what's going to happen here is we're going to lose the 0.1 precision, and it's going to do some truncation for us. So in this case here, the program would still run. We wouldn't get the results that we would expect because we have truncation. So let's get rid of this warning and just make this equal to the integer one. And now I'm going to display value once again, and you'll see that it should be equal to 100. Okay, nothing terribly fancy here. So if I do this, okay, I display 99, and then I display 100. All right. So let me show you something that's in the book again real quick. I alluded to the fact that integers there's a generic word for whole numbers, and in the C++ programming language, and most languages too, they have different types of integers based upon the size of values that you need to store in those particular memory locations. Just going to go through this real quick. These are actually machine dependent. So if you had this is valid, I believe it's on a PC. Let me see if it notates that here. It says depending on your operating system, the sizes and ranges may be different. I think this is valid for a PC. There's actually ways to test this, but nonetheless, this is sufficient. There's an operator that allows us to test how big these values can be. So here we have some different types of int. We have what's called a short int. Okay, a short int is typically just 2 bytes, and you can have a range of anywhere from this. Actually, this is a typo. This shouldn't be 232. This should actually be that's funny. There's an error in the screen or the electronic copy of the book. But the hard copy is fine. All right. What's happening is that this number 2 right here, this should actually be the negative sign. This number 1 right here, this should be a plus sign. So this should read the range is anywhere from 32,768 to 32,000. I'm sorry, a negative 32,768. To a positive 32,767. So just take a note of that. Okay, look at the copy you have in your book, and you'll see there's a negative sign there. So a short int, by definition, can contain both negative and positive values within this range. An unsigned short int, still 2 bytes, but since it's what's called unsigned, it will only hold positive values. So your range is still the same size, okay? But it goes from 0 to positive 65,535. So again, the size of the range is the same. It's just they're all positive numbers. All right. I believe you can see we don't need to call these short ends. We can just call it a short or an unsigned short. You can actually leave the int part off. Here, okay, with an integer type, we have 4 bytes. So the range can be anywhere. Again, this should be a negative sign. So this would be a negative, whoops, this is like a negative 2,147,483. I'm sorry, 2,147,483,648. So a really small negative number up to a positive, right? That one should be a plus sign. A positive 2,147,483,647. So this will accept both positive and negative numbers. The unsigned int, unsigned meaning that it only accepts positive numbers, will only store positive numbers. It's 4 bytes big, and it'll go from 0 to a positive 4,294,967,295. You get the idea. And then there's other ones, right? So we can have what are called longs and then longs. So the idea is that there's a bunch of different integer data types, and depending upon what the thing that you're trying to do is, you need to choose the right data type. Remember, these things use up memory, so it's you want to some degree conserve the amount of space that you're reserving in memory, so you're not making your program any bigger than it needs to be. But on the other hand, too, is you don't want to spend so much time trying to figure out, how to optimize your memory storage, because there's typically machines have a lot of memory, and you don't need to spend too much time worrying about running out of memory. More often than not, when we deal with programming, we work with either shorts or integers, because you can think about it here, right? If I have an integer, it spans, a signed integer, right? By definition, this is a signed integer. Plus or minus 2 billion. For a lot of computations, that's sufficient. So let me go back here to our IDE, and let's take a look at a couple little examples as to what would be the proper use of a integer data type. So let's say I want to do something with the college, and I want to keep track of how many students are in the system for any particular semester. A unsigned short, right? If we go back to here, remember an unsigned short can go anywhere from 0 to positive 65,535. That's way more than enough room to store the number of students that are registered at the college for any particular semester. It would make sense to use an unsigned short, right? The reason is because you're never going to have negative students registered, right? So the smallest value would be 0, right? So it's a good example where you would use an unsigned shorthand. So let me declare a variable that's going to contain the number of students, and I'll assign it a value. I just keep the screen a little bit clean. Let me get rid of this stuff here. All right. So I'm going to say unsigned short. Notice this is all appearing in blue, right? Because it's these are reserved words. And variable names typically should be given meaningful names, all right, that represent what the underlying data is being used for. So if I want to create a variable that's going to hold the number of students registered for a particular semester, this would probably be a good variable name, right? Num of students, right? Meaning the number of students. And here I'm just going to I'll declare it, and I'm going to initialize it to, I don't know, let's say it's about 2,500. I think that's a little high, but nonetheless, get the idea. We can put up to 65,535 in here. All right. So num of students is not only a good name, right? Because it tells me what it's going to be used for. It's also a legal name. So it begins with a letter or an underscore. Then it begins with the letter N, and then it's just the letters, number, scores, or numbers after that with no spaces. So num of students work. What if I wanted to have another variable which is going to contain the population of the United States? I don't know what the exact population is, but it's 300 something million. All right, so if I wanted to have a variable that held something of that size, I wouldn't be able to use an unsigned short or even a short, right? Because a short only goes up to an unsigned short only goes up to 67,535. So I would need to use a different integer data type. In this case here, it would probably make sense to just use an unsigned int. All right, so if I type unsigned int, I'll call it US population equals, I don't know, it's 350. Is that right? One too many, I think. No, that's 35 million. I had it right before. 350 million. All right. So my variable is called U.S. population. That will contain the population this time, which is about 350 million. Remember, an unsigned short can go up to an unsigned int can go up to just over 4 billion. So this is more than sufficient to store 350 million. You may have noticed, all right, I kind of used a little bit of different naming convention between my first variable and my second variable. This variable here, okay, it uses something that's called, it's typically referred to as what's called camel case notation, right? So the idea is that you have a couple words that you're trying to put together, and somehow you want to be able to sort of delimit the words without the use of space, right? Because we can't have space within our identifiers. So the beginning of each word, okay, starts off with a capital letter. So here, of starts with an O, student starts with an S, and everything else is lowercase. So that's what's called camel case notation. Another way that you might want to declare your variables is if you have more than one word that you want to put together, is you could just use like this kind of notation where you have a word, like US, or it's an abbreviation, all right? Can't have a space, but what you can do is you can have an underscore, and then you can have the word population after that. So whatever works for you guys. I mean, feel free to use whatever you want to do, but it's always a good idea to be consistent. But more importantly, make sure that your variables are meaningful, right? Their names of the variables are meaningful, right? So if I wanted to store the U.S. population in a variable, this probably wouldn't be a good variable name. While it's acceptable, I mean, the compiler doesn't care, right? It just knows that X is assigned some value, 350 million. To us in the program, it doesn't make much sense because it doesn't describe what the data is holding. So let me put that back. All right. Let me, before we go on to the character data type, let me show you what happens if we try to stick something too large into a integer data type, or actually really any data type for that matter. So let me create a variable of type. I'm going to create another small integer. I'm going to call it short. I'm going to call it max short, and I'm going to declare that and initialize it with the value 32,767. Where did I come up with this number? Right, if we go back over here, remember a short or a short int, you can leave off the int. Okay, by definition, it's included there. The range is from a negative 32,068 to a positive 32,767. Now, if I have 32,767 stored in my variable that's called max short, let me display that. So I'm going to say cout. I'm going to say max short value equals. Remember, you need to have the stream insertion operator repeated again here because we're going to put something else onto the right. I'm going to say max short, and then we're going to do end L. Let me build it. And this will display the string max short value, and then it'll display what the value is of the variable that's called max short. So if I run this, right, so his max short value is equal to 32,767. Let me get rid of that. You'll notice too, right, these two variables that I created up here, num of students and US population, I declared them in my program. I initialized them with some values, but I never did anything with them. Okay, meaning that I never displayed them, I never did anything else with them. Compiler's fine with that. It's not going to render an error for that, but just be aware that just because you declare a variable doesn't mean it's going to be used anywhere on the on a screen or what have you, or within your program. Okay, these are just memory locations that you're reserving. They're reserved, but you're free not to do anything with them if you want. All right. So what I want to do now is let's see what happens if I take my maximum short, and I'm going to assign that to whatever its value is, and I'm going to add 1 to it. All right. I'm going to go down here, copy this down here, and I'm going to say max short plus 1. What do you think is going to happen here? You might want to just think about this logically for yourself, and do you think that it's going to do you think it's going to compile? Do you think it's going to generate an error when your program runs? Do you think we might get some other kind of result? Let's see what happens. One of the nice things about computer science, like if you don't know what something is going to do, just try it. More often than not, you're not going to cause any harm. Again, assuming you don't do something like delete something from a drive or whatever. But more often than not, you can always say, what's going to happen if I did this? Well, just try it. Let's see what happens. So let's run this, and let's see what we get. So Control F5. I didn't build it, so many of you have probably already seen this, right? So meaning I made changes to my code, but I didn't build it, but I'm trying to run it. So this is a little helper thing with the ID. It'll just ask me if I want to build the thing. I'll say yes, right? So I'll build it. And now what happens? So this is a little strange, right? So if my maximum short value that I can hold is 32,767, if I add 1 to that, why am I getting a negative 32,768? The reason is because what I did here is I forced what's called arithmetic overflow. So you can think of think about it this way. Let me go back to the book. Well, first let me kill this window. So remember, this is negative 32,768. So I cause arithmetic overflow. What happens here is this is the value that's all the way off to the right, positive 32,767. This is the value that's all the way off to my left. So you can kind of think of this as like as a number line, but the number line, imagine taking the number line, like it's written on a sheet of paper or something like that, and you folded it around so that both ends touched. So you can kind of think of it as a Q. So as you increment it, you can keep incrementing values, but once you kind of get off to the right and you get to the end, it's just going to loop back around again to the left, okay? Because the number line doesn't go on infinitely in both directions, but it connects, if you want to think about it that way. If we were sitting in the classroom, I could draw a better picture for you on the board, but I think you can imagine what a touching number line would look like or something like that. All right. Now if I go back over here, right? So if I increase this by 1, well, what's going to happen? What happens if I would decrease it by 1 again? Well, then I should just go back in the other direction, and I should get back to where I started. So let's imagine I'm just going to do a little quick copy and paste here. Here I'm going to say max short is now equal to max short, and I'm going to subtract 1 from it, and I'm going to say max short minus 1. Now I'm going to build this again. All right, so I'm going to display the maximum short value, generate arithmetic overflow here by incrementing beyond the upper bounds, and then I'm going to generate what's called arithmetic underflow, where I go too far to the left and then I loop back, I backtrack around off to the right. And by doing this, we should get back to the original value, which is 32,767. All right, so that's pretty much it with integers. One thing that I want to show you guys real quick, and this is a common error, and I just want to make sure everybody's aware of this. Let me kill this stuff up here. Let me kill this stuff down here. Let me move this down below this. All right. This is a common error. Okay. What did I do? All right. I created a variable of type short and I called it max short. Totally fine. And I initialized it to a value 32,767. However, what I did is up here in my cout statement, I'm trying to use a variable that's called max short. However, up until this line, right on line 6, that variable max short has not been declared yet. So the compiler is going to complain because it literally compiles from top down. So if you hover your mouse over the little red squiggly line here, you'll get the error right in here. It says error identifier max short is undefined. What does that mean? Is that it's not defined yet. Okay, so and this is the easiest way to think about it, is that before you use a variable, okay, you must declare the variable, right? So here I'm trying to use the variable. I declare the variable down here. So what I need to do is put my declaration back before my consumption of the variable. So again, that's a common mistake. Again, just think about the compiler it's like you're reading a book, right? You read from top down, and that's what the compiler is doing. All right, so that's pretty much it for integers. I would highly recommend reading this section in the book. It's a good little subsection of the chapter. And now what I want to do is I want to talk a little bit about another type of integer, which is called the character data type or the char data type. All right, the last thing I want to talk about for this lesson is another type of integer, which is called the char, C-H-A-R, or the character data type. The way that the C++ language stores characters, okay, things that we think of as characters, is actually via really small integers. And most programming languages and computers and smartphones or what have you do that. They take a numerical representation of a letter and they store that they take a character representation of a letter and they store it as a number. So you can think of characters as just behind the scenes, really a small integer. So let's take a look at an example here real quick. So here's a data type. It's called char. Okay, char meaning character. All right, and I'm just going to create a variable that's called letter, and I'm going to assign it the letter B. So the way that you assign character literals to the char data type is via the single quote. Okay. So there I created a variable called letter. Notice it's a legal identifier, right? It starts with a letter or underscore. It doesn't start with a number. Doesn't have any special characters in there, and it's descriptive, right? Letter, right? Meaning it's going to hold a letter. And the data type is of type char. All right, so char is a reserved word, and hence you'll see that it comes up in blue. So what I can do with this, I can do cout letter equals, remember, stream insertion operator, and here I'll type letter. All right, this is just going to display the letter B to the console. B without the single quotes. Okay, so if I do this, Control F5, Control F5. Okay, letter is equal to B. Very cool. Because behind the scenes, B is being stored as a number. So the letter B, okay, is actually stored as the number 65. So if I did this, let's say, is it 65 or 60? I think it's 66. So if let's say I take letter and I assign it the number 64. Like, well, why is he doing that? Because letter is a character data type. Why is he assigning a numerical value to letter? Well, the reason is because there's a representation. I'm going to show you guys a table in a second, which maps the underlying number to the corresponding letter BAA, what's called the ASCII table. So now what I can do is if I display letter now, all right, we'll see that letter is now changed, okay, and it will be the number. Oh, I was off by one. Letter B. What did I do wrong here? Let me go back to my. Let me pause for 1 second. Yeah, let's do this. You know what? Here, I made a mistake. I think B must be 66. Oh, I'm sorry. This has to be 65 then. Right. There's a way to check this without doing on in your head. I'll show you in a second. So if I run this, so now we get back the letter is equal to A. All right. So what's going on behind the scenes? All right. So here. There is something that's called the ASCII character code table. You can do a quick Google search on this. It's a standard, or it's in your book. And let me see if I can find it in the page. I think it's in the appendix back here. Page, I think it's page 1211 or something. Let me look here real quick. Yeah, 12. It's in one of your appendices. Appendices. Not appendix, appendice. So page 1211, the computer's hung up here. All right, here we go. So in your book on page, I believe it's page 1211, plus or minus a page, here are what are called the printable ASCII characters. All right. So the first column here is what's called the decimal equivalent, like the base 10 numbers like we think. The hexadecimal equivalent, the octal equivalent, and then actually the underlying characters. So you can disregard the middle two columns here. The table in your book is actually laid out better than the electronic copy here. So if I go down here, so I have the decimal equivalent and the character. So if I scroll down here to the decimal number 64, right? So the decimal number 60, I'm sorry, not 64, so off by one. Decimal number 65. That corresponds to the capital letter A. The decimal number 66 corresponds to the capital letter B. 67 corresponds to the capital letter C. And these continue on from A to Z. Uppercase letters are first. Then you have some special characters. So for example, decimal number 91 corresponds to the open square bracket. Right. Go down a little bit further. Decimal number 97 corresponds to lowercase a, 98 is lowercase b, so on and so forth. So you can see that there's a whole bunch of characters, okay, that are printable, and there's also a bunch of characters that are non-printing characters. So if we go back up to this other table again, I think it's laid out slightly different in your book. So the decimal equivalent 0 corresponds to what's called the null character, or you can kind of just think of it as the empty. You can just think of it as blank or empty. The decimal number 10 corresponds to the new line character, which on most machines would correspond to the endl or \n. And there's a whole bunch of other ones. So all of these things here are things that are non-printable. We're not going to cover too much of this. They're not characters that we're going to come across, but it's the printable character code set that we're concerned with. I would, if you want to look at the ASCII character code table, just do a Google search. Actually, there's plenty of ASCII tables that are out there that are laid out better than this thing. So let me go back to my my program over here, and let me show you. We can do, since characters are behind the scenes numbers, we can do arithmetic, okay, on characters. Meaning I can do something like this. I can say letter is equal to itself, letter plus, all right. So if 65 is equal to the letter A, then if I say letter plus 2, okay, that would mean A plus 2, or letter should then be equal to C. And if we do this, all right, if I build this, we'll see that we should print out the letter C as the last output, right? Because letter plus 2, the 67, go back to the ASCII character code tables, and you'll see what the mapping is. One thing I want to mention to you, though, here's a common mistake that students make. Characters, okay? A character, if you want to assign a character literal to a character variable, you must wrap the character literal in single quotes. If you do this and you use double quotes by mistake, the compiler is going to complain, and the error is going to be something like, here, this is fairly probably non-descriptive to many of you, but what it's saying is this: a value of type const char star cannot be used to initialize an entity of type char. What does that mean? Is that this is saying in technical terms, you can't take a string and assign it to a character. Okay, so that's a common mistake. So make sure that you use single quotes. Another thing is that a character is a character. It's not plural. All right. So if I have the character B, I can't do something like this, okay, and assign it to letter, because A and B together are, actually, maybe this is doing Unicode. Let's say A, B, and C together, right? That's not a character, right? But that's a sequence of characters. So imagine if I compile this, I'm going to get some kind of warning, all right? And here it's doing some type of truncation from int to char. So internally, it must be doing some kind of conversion with ABC into an integer or something, and then trying to convert it to a char. I don't know what's going to happen here. I'm kind of curious myself to see what's going to happen. By the way, when you're building your program, when you come across compiler warnings, okay, compiler warnings will allow your program to still build. Compiler errors will not allow your program to build. So I can build the warning and execute it, and let's see what happens. So I get the letter C for the first one. So my guess is that it's truncating this stuff here. Let's say I made this ABZ. Let's see what happens. All right, still doing some truncation. I guess it's sign Z. Anyway, it's a bad idea. Don't do that. So even though you're getting a warning, you could continue on. It's not a good idea to run your program when you have warnings, unless under certain circumstances, and I'll try to cover that for you. So that's it for this lesson. Let me show you what lab we're going to do today. I'm sorry, for this week. And I believe it is on page 79. Let me look here real quick. The computer's slow again. I don't know why. My internet connection is not so good today. All right, so this is the lab that I was trying to get at. My internet connection went down for a second there. All right, it's just going to be lab number 1. I was actually hoping to get a little bit further and talk a little bit more about the floating point data types. So we could do some of these other labs, but that's fine. This lesson is already an hour and 15 minutes. So we covered a lot. So let's we'll start off with the floating data points on our next lesson. So what we're going to do is, I know not everybody has the book, so that's why I'm presenting this on the screen here. So what we're going to do is on page, I believe it's page 79 of the textbook, it'll be lab number 1. Okay, and here you sum up 2 numbers. You write a program that stores the integers 50 and 100 in variables and stores the sum of these 2 in a variable named total. In addition to that, display the value of what total is. All right, so the value of total at the end of the day should be 150. Just display that to the screen. Okay. So you can think about this as kind of interesting, right? We spent probably about a good hour going over a lesson. And at the end of the lesson, your goal is to go ahead and add up the number 50 and 100 and display the result. Sounds kind of trivial, right? I mean, you could do that on a in your head, first of all, or a piece of paper or a calculator or whatever, and it would have been done, a good 59 and a half minutes ago. But nonetheless, we covered a lot of introductory things into programming and data types and variable names, all that good stuff. So anyway, so that's it for this lesson, and have a good week.